Let's consider P2 again. Consider P2, the set of all polynomials of degree less than or equal to 2. And let's look at three vectors in there. We have t squared plus t plus 2. We have P2t, which is equal to 2t squared plus t. We have P3t, which is equal to 3t squared plus 2t plus 2. So they're just, random vectors in this particular space. In other words, random polynomials. Well, we want to know if these three, as vectors, are they linearly dependent or independent? Well, do what we do. We set up equation 1, which is the following. We take arbitrary constants, c1 times p1t plus c2 times p2t. We'll write everything out here. We want things to be as explicit as possible. Plus c3 times p3t, and we set it equal to 0. That's our homogeneous system. So now we actually expand this by putting in what these p1, p2, p3 are. Okay, we get c1 times t squared plus t plus 2 plus c2 times 2t squared plus t plus c3 times 3t squared plus 2t plus equals 0. Now let's actually, this one I'm going to do explicitly. There's no particular reason why, I just decided that it would be nice to do this one explicitly. So I have c1t squared plus c1t plus 2c1 plus 2c2t squared plus c2t plus 3c3t squared plus 2c3t plus 2c3 equals 0. Algebra makes me crazy, just like it makes you crazy, because there's a whole bunch of things floating around. Tough to keep track of it all. Just go very, very slowly and carefully and be systematic. And don't ever do anything in your head. That's the real secret to math. Don't ever do anything in your head. You won't be impressing anyone. I collect the terms, the c2t, the t squared terms. So I have that one, and that one. And I end up with, so let me write these out as t squared times c1 plus 2c2 plus 3c3. And then I'll take the t terms. So there's a t, there's a t, there's a t. And I'll write that as a second line here, just to be clear what it is that we're doing. c1 plus c2 plus 2c3. Then I have plus the rest of the terms. That one and that one. And is there one that I'm missing? No, looks like it's okay. So it's going to be plus 2c1 plus 2c3, and all of this sum is equal to 0. Well, again, that means this is 0, this is 0, this is 0. That's what this system is. So let me write that, right? Because everything is 0 on the right, so all of these have to be 0 in order to make this left side 0. So I get c1 plus 2c2 plus 333 equals 0. Nope, we don't want these lines floating around. We want to be able to see everything here. C1 plus C2 plus 2C3 is equal to 0. Then 2C1 plus 2C3 is equal to 0. This is, of course, equivalent to, just take the coefficients, 1, 2, 3, 0, 1, 1, 2, 0, 2, 0, 2, 0. Okay, so this is the system that we want to solve, and we're going to subject that to reduced row echelon. So I'll put a little arrow to let you know what's happening here. And what you end up with is 1, 0, 1, 0. 0, 1, 1, 0, 0, 0, 0, 0. So let's take a look at our reduced row echelon. We have this is fine. Yes, that's a leading entry. That's fine. That's a leading entry. There's no leading entry here. And remember, when we solve to reduced row echelon for a homogeneous system, this means we have an infinite number of solutions because this one can be any parameter. And if this is any parameter, well, I can choose any number for this one, and then that means these two will be based on this. Therefore, we have infinite solutions. In other words, there does exist a non-trivial solution. So, there exists a non-trivial solution, which implies dependence. And what that means is that those three polynomials that I have, one of them can be expressed as a linear combination of the other two. So they're not completely independent. At least one of them depends on the others. So we have dependence. So again, today we talked about linear independence and dependence. Previous lesson we talked about the span. So make sure you recall how we're still solving a linear system when we do that, but for the span we choose an arbitrary vector. That's our solution on the right-hand side of the equation, that linear combination that we write. For linear dependence and independence, we're solving a homogeneous system. We just set everything equal to 0. Make sure to keep those straight. Thank you for joining us here in the discussion of linear algebra, Educator.com. We'll see you next time. Bye.